a small topic here. This is the last one. I shall open in whiteboard. The last one, it is a note given in textbook, last page of this chapter. If A and B and C are three consecutive terms of an arithmetic progression, we can write B is equal to A plus C by 2. That's the arithmetic mean of A and C. So we can give a small proof for this. If they are consecutive terms, we can write A as B minus D because they are in arithmetic progression. So if you subtract a common difference from any term, you will get the previous term. So A will be B minus D and C will be B plus D. If you add common difference, you will get the next term. If you add D to B, you will get the C because these three are consecutive terms. And if you add A plus B plus C, if you add A plus B plus C, here you will get A is B minus D. So B minus D plus, for B we can write B itself, and for C we can write this B plus D. Okay, so here many things you can cancel. So here minus D and D you can cancel. From left and right you can cancel one B. The balance is A plus C is equal to B, 2B, B plus B 2B. And you can move 2 to left side. So A plus C is equal to, A plus C by 2 is equal to B. This is what here, right? So this is a note you can apply in some problems. So I am winding up this lesson. So we can look all the topics we covered in this chapter. Okay? So we started this chapter with a definition of arithmetic progression, and we saw some positive and negative examples. We know the definition. An arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. And that number we add is called the common difference, right? Also, we can define common difference like this. Common difference is the difference of two consecutive terms in an arithmetic progression. It will be same everywhere, okay? And it can be positive, negative, or zero. And then we discuss the general form. A plus D, A plus 2D, A plus 3D. General form of an AP, right? Not a term, general form of an AP. Okay? And then we discuss the finite and infinite arithmetic progression. For finite sequence, the sequence will terminate at a point. But infinite progression will continue. And then the term formula, we discuss a very important part of this chapter. An is equal to A plus n minus 1D. And then general term of an AP is AN. Okay, AN. The last term we can denote by AM or L. In this chapter, we denote only using L. If it is finite, this L is used only if the sequence is finite. And then the sum of first n terms of an AP, we saw these formulas. The formula to find the sum of first n terms of an arithmetic progression is S is equal to n by 2 into 2a plus n minus 1d. And we can also write the same as S is equal to n by 2 into a plus a. If the sequence terminates, if the progression is finite, S is equal to n by 2 into a plus n. And then the sum of n positive integers, natural numbers. That is this. The sum of first n positive integers, natural numbers, is given by Sn is equal to n into n plus 1 by 2. Today we discussed if A and B and C are three consecutive terms of an arithmetic progression. We can write B is equal to A plus C by 2. That's the arithmetic mean of A and C. Okay, so see you next time. I wish you a nice day. See you. Bye.